Miss Ryan, how are you today? It's Friday, yeah? Good? Good? It's Friday, yeah. Okay, so today we talk about a problem which is called set split. Set split. We want to, so given a list of numbers, yeah, list of numbers like 4, 9, 5, yeah? Okay, let's read numbers. Okay, so this is a set of numbers. We want to find out if it's possible to split the numbers into two groups, okay? So, two groups. Each group should have at least one number, okay? It cannot be an empty group. Yeah, does it make sense? So two groups. And first requirement. Second requirement is the sum of both groups are equal. Sum of each group, sum of both groups equal, yeah? And the third requirement is one group, the numbers in one group are strictly smaller than the other groups. One group numbers strictly smaller than another, okay? So for example, I can split this into two groups, 4, 5, and 9. 4 plus 5 equals 9, another group, yeah? The second, okay? And 4 and 5 are strictly smaller than 9. Okay, so can we do this with 9 and 9? Can we do this? Can we split this into two groups? No. Why is that?
Because SA only can be split in 9 and 9, and 9 is not strictly smaller than 9.
Well done, good job. Okay, so how can we do this? So can we find a way to do this? How can we do this?
Brute forcing.
Yes, how can we brute forcing? How can we brute force? How can we brute force? How can we brute force? So the brute forcing will be picking the numbers of one group, right?
Mm-hmm.
Picking the numbers of one group. So for each number, we can try to pick in one group or not pick one group, right? Right?
Mm-hmm.
So eventually this will be in two groups, A and B. So if we decide the numbers to put in A, then we also mean that we have numbers in B, right? Alright?
Mm-hmm.
So this number, I can have two choices. The next number, I can also have two choices. If there are n numbers, how many choices do I have? I have two choices. So for n numbers, how many choices do I have?
N times
2 to the power of n, right? Because 2 times 2 times 2, right? Yes?
Mm-hmm.
So this is the number of ways to split the groups. And then we also need to find out if the sum are equal. It takes n times, right? It takes n times to find out the sum, right? Of course, we can calculate the total sum, right? Yeah, total sum.
Mm-hmm.
And then if we find out the sum of one group, we can use the math to calculate the sum of the other group, right? Does it make sense?
Mm-hmm.
Yeah. By the way, these numbers are all positive. Okay, it does not contain the negative numbers. Does it make sense? Okay. So this approach is a bit slow, yeah, because the overall term complexity is this, right? This is exponential, yeah. It's very, very slow, yeah. Yeah, am I right? Yeah.
Yeah.
Okay, so can we do better?
Maybe we can.
Maybe we can't. Okay. So I give you a hint. How about we sort the numbers? We make it the numbers from the smaller to the biggest. So in this case, 495, we sort the number. 459, okay? Alright?
You go like that, then it's not, then that.
Yes.
Easy!
Yes, why this is working? Because it is we sort the number from the smallest to biggest. Right?
Yeah.
So because eventually the sum has to be divided into two sum, right?
Mm-hmm.
So if I continue picking the smallest number, eventually it will be the same. It will be a cases that it will be the it'll be either half or more than half, right?
Mm-hmm.
Yeah, okay. So let's think about other examples. Like so look, is that 4? Is 5? Look. First of all, we need to calculate the sum of all this, which is 18, right? This can be done using O(n) time, right? Yeah?
Yeah. And then you
Go
split
through.
it.
Then look, then I have a running sum. So 4, is it times 2 equals, if it is equals half, will be 9, right?
Yeah.
Is it half to 9? No. I add the 5. Is it half 9? Yes, right?
Yeah.
When it's yes, it means that I have I found a half. But I also need to compare that if this number is strictly smaller than the next number, right? Right?
Yeah.
If it's smaller, then yes, we found a group. If not, let's say if not. Okay, so let's do this. If
That's a new example.
yeah, we have to give another example like 9 and 9. Okay, so right, the file here 9 is half of the 18, and it's not strictly smaller than the next one. Then it's not, right? Yes. Does it make sense?
Yeah.
Okay, so how? I mean, any other possibilities that this algorithm may not work? I mean, can you think of any example like it may break, for example?
That the one you just said.
Which, oh yeah, no. I mean, is it that will still work? I mean, we just need to
If you
return.
just add it and.
Yeah. So for example, like let's try another example. Okay, so you pick one example like 2, 4, 9, 10. Okay.
Yeah.
So can you go to after adding these numbers? What's the sum? 25, right?
Yeah. You can't do it.
You can't do it because it's odd number. It's not possible, right?
You only can do this and that, which is the.
No. What I'm saying that is that we calculated first time I calculated the sum of all numbers, which is 25.
Yeah.
So I know it's impossible.
Yeah.
Why is that? Because 25 cannot be divided into 2.
Yeah.
Okay, does it make sense? Yeah. Okay, so now if I put a 11 here. Okay, so now that would be 26, yeah? 26, and then I'm looking for 13, right? 13.
These two and these two.
Yeah. So
The
does it?
middle two and the end two.
Okay, wait.
These two and these two.
No. So that's what? 6 plus 4, 26. 26 is 13, right? 13. So
These two and.
okay, so that algorithm work or not? Look, 2 plus 4. 2 plus 4, 6. 6 plus 9,
15.
15.
15 plus.
So you say, so
I can't see.
so it's not. But why you saying this is okay? Because look, 2 and 11, 4 and 9. This group and this group, the numbers here are not strictly smaller than this one because 11 is bigger than that, right? Does it make sense? Why? That's why we need to sort the numbers because we want to make sure the numbers in one group are strictly smaller than the other group. Does it make sense?
Yeah.
That's why we sort it. Even though you can find 2 plus 11 equals 4 plus 9, but still it's not possible to split into according to the third requirement, which is the numbers in one group are strictly smaller than the other one. So this may not work, right? So the algorithm we pick is right, yeah? Because look, 2, 4, which is 6, 6 plus 9, 15 is bigger than 13. Then we know it's not possible to find such thing, yeah? That's why we need to sort it. Does it make sense?
Yeah.
Okay, any questions so far? No?
No.
Okay, let's do this. Define set split num and
Column.
okay, now look. Let's say sum equals sum. How can we find the sum of all the numbers in nums? Can you write a for loop? Like look, s equals 0 and then what? For I in num. Right, look, Eric. What should I put here? If I want to add all numbers of I. All the numbers in the nums.
Nums.
Yeah, I want to sum all the numbers in nums. How can I do this? And put it in S. So what should I do? S what?
S E.
I want to add all the numbers and put it at S. S what? What?
S.
What should I do with S and I? Come on, a little quiz. Come on, it's easy. Come on. Add what?
Add I.
Add equals I. Come on, this is simple, yeah. But
I
you,
for that.
yeah, but you don't need to write this, right? Because this is getting all the numbers sum to S. We can just do this function sum. Yeah, yeah. That's it. The same thing. You see, the same thing, yeah. Okay, now if S is odd number, how can we write it? If S modulus 2 equal what? If it's odd number, so equal what? If modulus 2, if it's 1, and I know it's not possible, yeah.
Return false.
Okay, modulus 2 can also be written as S and 1, yeah. It's the same thing, yeah. Remember this bit, binary, yeah. If you end 1, if the last bit is 1, it's odd number. If it's 0, it's even number, yeah?
Yeah.
So this and this are equivalent, the same. Does it make sense? Modulo 2 is the same as at n1, okay? Now, I have a continuous sum, c equals 0, and then look, for I in range length num, okay? I want to iterate the numbers, the index. Okay, then look. C, I need to add equals I, right? Yes?
Yeah.
If C times 2, right? C add C equals what? Equals which number? Equals which number? If now I add it to, I times 2 equals which number?
The sum.
Yeah, S, right? Because if add it 2 equals sum, it means we find a half, right?
Yeah.
And also num I needs to be, current number needs to strictly smaller than which number? Which number? This number needs to strictly than what?
The next one.
Next one is nums what?
Nums.
What? Current number is I, what's next number?
I plus
1, come on, okay. And column, return true, right? Return true. Okay, if C times 2 bigger than S, it means that we are crossing the half, right? We're crossing the half.
False.
Return false.
And
Wherever.
return to false again.
No, return false again? No, after this. Yeah, return false again because we can't find it, yeah?
Yeah. See, I told you.
Okay, yeah, well done. Yes. What's the time complexity?
No, wait, n something. Or something.
What?
Look, n. No, I mean, no, it's n square.
Okay.
N log n.
Where?
N square. N.
Come on, no, yeah. Here I forgot that we need to solve the number. The numbers don't solve, yeah? Remember?
Yeah.
And this is
I
over.
knew that.
Over. This is over. Remember?
No way.
And log n. Come on, I
Log
told
n.
you a few days ago.
I
And this
already
bit.
said that.
And this bit.
Yeah.
And this bit is how much complexity?
N.
Oh, n. And so overall time complexity is which one? Which one is bigger?
O-N.
Oh, and log n. Come on.
Yeah,
This one
I
is
knew
bigger.
that. Why? I just said
Why?
O-N, log n.
Because look, log n can be bigger than 1. So n times something bigger than 1 is definitely bigger than n, right? Alright?
Yeah.
Log n, log 100. Log 2 base 2 equals what? Equals 1, right? Log 2 base 2 equals what?
That's 4.
Yeah, 2 4 equals what? 2 times what? 2 to the power of what equals 4?
Well, 2.
2, yes. Okay, log 2 16 equals what? 2 to the power of what equals 16?
8. No.
2 to the power of 4, yes, come on. So do you get it? So this n, this will be bigger than 0 because log n is like that. Is this, yeah, log n. Got it? Does it make sense?
And like that.
No, log n, look. N, y is log n, and this is n. So when n is 1, it will be 0. When n is 2, there will be 1. So it will be like that, right? Does it make sense? Yeah? So this is negative, you don't need to worry about that. So n, look, log n, this is 1, because log 2 1 is 0, yeah, because 2 to the power of 0 is 1, right? Look, yeah, 2 to the power of 1 is 0. So n, when n is 1, x coordinate is 1, then y will be 0, right? This is y, right? Does it make sense? Yes? Look, another thing, okay? Another thing. Log 2 to the power of a times
A
times b.
times
B equals log 2a plus log 2b. Let's try if it's alright, okay? Look, log 2, let's say 2 times well, maybe 4, okay? Let's see if it's 4. Log 2a, this is 3, yeah? Alright? Alright? 2 to the power of 3 equals a, right?
Yeah.
And this is, if this will be log 2 plus log 2 4, right? 2 to the power of 2 is 2 to the power of 1 is, this is 1, right?
Yeah.
This is 2, right? 1 plus 2 equals 3. Okay, does it make sense? Log 2 AP. So basically it's log XAB equals log XA plus log XB. And another formula, yeah? Look, when it times, you can plus, right? So when it divides, when A divides B, right? And then this will be minus, right? Because A times B equals A divide. Look, A times B actually is the same as A divided by, right? A quarter over B, yeah? Am I right? Does it make sense? It's the same thing, yeah? It's the same thing. This is the same as this, right? Am I right?
Yeah.
Look, 2 times 3 equals 2 times 2 divided by 1 over third, yeah? 2 times 3 equals 6 is the same as 2 divided by a third, yeah? Am I right?
Yeah.
It makes sense, okay. Another thing, okay, a little bit more, okay. Log 2 to the power of 3 here equals what? Alright,
Yeah.
just equals, you can put this in the front, that will be 3 times log 2, that will be 3, yeah. Let's try, log 2 to the power of 4 to the power of 2. Okay, so you can put this here,
4.
and that will be 2, so that will be 4, yes. Does it make sense?
Yeah.
Because log 2 to the power of 16 is 4, yeah, it's the same thing. Yeah, does it make sense? Yes? Okay, so a little bit far away, okay? So this is O log n, right? O n log n, this is O n. So this is bigger, so we pick this one. This one is the most dominating, most time consuming part of the algorithm, right? But this one is trivial compared to this one. So the overall time complexity is O n log n. What's the space complexity?
The space complexity.
Oh what? Do we use extra space?
1.
Yeah, O1. Come on, O1. Okay. Okay. What's here?
Something with 2.
What's here? Okay, the last one. What's here? What are we checking here? What are we checking here? If we need to find the half, right? So how do we check it there?
C.
You what?
C times thingy, I don't know.
C times what? How many C will equals to?
2.
Yeah. C add 2 times 2 equals what?
Equals
Equal.
S.
Yeah. Or C plus plus. Or C plus C. You can also C plus C equals S, right? It's the same thing, yeah? Or C equal S divided by 2, yeah? It's the same thing, yeah?
Yeah.
The thing is that we want to check if C is half of S. If it is half of S, it means that we find half of it, right? And we also need to check if the current number is strictly smaller than the next number. If it is, that it means we find the two groups, which one group is strictly smaller than another group. Then we return true. Yeah? In all other cases, we return false. And can we actually remove this?
What?
If we remove this bit, does this argument still work?
Maybe it does. Maybe it does.
Yes or no? Come on, yes or no?
Maybe or maybe not.
So what are we checking here? We want to return false, right?
Yeah.
If we're not returning false, it will be returning false here, right?
Yeah.
So it will still work. But why are we adding this? To make it faster, right?
Yeah.
Because if as long as we can't find such half, we can just return false, right? Because it's no point to continue searching the another half of the array. Am I right? Does it make sense?
Yeah.
Are you sure?
Yeah.
Okay, tell me why we need to add this.
Okay, so it is no point to check the other half of it.
Why is that? When is that true?
When. Okay, so
Understand why? When C what?
when C is 2 of C makes F.
Yeah, when C is more than half, it means we don't need to continue, right? Because they are all positive numbers. If we continue, it will be more than half, right? So there's no point to continue. So we are returning early access. So that makes it faster, right? Does it make sense? Okay. Okay, that's it. Okay, that's it. Thank you. Thank you very much. Did I say?
Bye.
Bye bye.